Hi, welcome to another Hopper on microcontrollers video. This is more of a electronics RTFM kind of video than a Hopper video. But I made this mistake, so could you. Anyway, if you've been following along for a little while, you'll know that I'm quite partial. I'm quite partial to USB-C connectors. Like this one. Where are we? Yeah. So a USB-C connector on a Raspberry Pi Pico clone, as opposed to the Raspberry Pi Pico guys who haven't updated their model in too many years, and they're still on this little tiny, unusable USB socket. So I far prefer USB-C sockets. Anyway, um, I wanted to get Hopper running on this tiny little RP2040 stamp from Solder Party. So I ordered one. In Australia, the place to get them from is these guys, Little Bird Electronics. And here it is. It's pretty tiny. Compare it for size to a regular Raspberry Pi Pico. It's quite small. So the one thing you're going to need to make this work is you're going to need to have you need to connect power and a serial port to it, to program it. So let's see how we do that. So the first thing I was keen on USB-C rather than so I was looking for breakout boards for USB-C, and when you look across, you go, well, I'm going for tiny here, so this one's pretty tiny. So that's the one I ordered. Without thinking like there's anything to it. Just like you can because previously I used USB but not USB-C to power my original 6502 board, and you just wire it up just to the power and it works. You just need two pins, the power pins. So I thought the same would be true because why bother reading the data sheets? So there's a couple of things I don't like to see online. It's like when you ask a question, people say, "Oh, go read the data sheet." It's like if I wanted to read the data sheet, I wouldn't have asked in this forum. And the other one is you're doing it wrong, or why are you bothering with this project at all? So I prefer the more constructive responses. Anyway, so this is one of them. I'm not going to assume that you've read the datasheet for USB-C any more than I have, because I have no interest in USB-C. I have interest in getting my board working. And when you do go and read the datasheet on it, it's actually, or just read Reddit threads on it, it's more confusing than you'd think. Anyway, so yeah, I ordered this one. It's an Adafruit breakout. It arrived in the mail, and let's hook it up and see how well it works. Okay, so I've hooked it up, plugged it in, and what are we getting out of that? Nothing. Background noise voltage. So I've plugged in two wires. It's plugged into my USB-C, and I'm not getting any power. Why? So that led me to go and try and do a little bit of reading. First time around didn't work, so maybe we actually might need to go read. So I went and read about, and it took me a while to figure out what question to ask, right? So what are these other pins on the USB standard? And if you read about them, they talk about upstream mode versus downstream mode, all this sort of thing. And then there's all this 56k resistor you need to have on it, etc., etc. And then if you scroll down a bit, it's now no longer a 56k resistor, it's now a 5.1k resistors to ground. And what it is USB-C is kind of smart in terms of, the short version of it is, on the device, the CC pins need 5.1k resistors to ground so that the source knows the cable orientation and that it needs to connect the power. And you can change this resistor to tell it what the max power should be. And it's a safety feature in a way, so that if the power supply detects more current being drawn than what's spec'd by the resistor, it can cut the power. Or if there's no resistor, it doesn't give you any power at all. So that's why there's no power coming through this. right? So let's have a closer look. We go and sort of just do a Google search on buying a breakout board, specifically look for the Adafruit one, but there's Sparkfun ones as well. If you take a closer look at these guys, they have, let's see if I can get one in. Yeah, this one's good. You can see here on the breakout board, there's two little, surprise, surprise, 5.1K resistors on the board. And my original board didn't have these. So if we look at the two other little boards I bought, where are we? Two little resistors. And on this one, the resistors on either side. So let me hook these up and see how well they work. All right, so this is the Sparkfun one hooked up. And our little LEDs on. And we've got 5 volts. Let's go have a look at the other one. I've hooked up the second one. This is the Adafruit one. And again, LEDs on. And we've got our 5 volts. So now you know what I do. I think there's obviously a reason that the other ones exist without the 5 volt, without the 5.1K resistors hooking these CC lines for you. And that's probably because your circuit's already got them built in. So you need to have both variants. But now you know, it's not all USB-C breakouts are the same. And it's not clear if you go and I read the day after I failed, I did a lot more reading, and it wasn't clear from the pages on their sites. They don't classify them differently. Like this is a breakout with resistors, and this is a breakout without resistors. So they don't clearly show which ones have the 5.1K resistors on the CC lines. So you can make it out if you look in the pictures. Like flip the thing over. Is there a resistor on this board or not? But there you go. How to pick your correct USB-C breakout. And now I can get on with the more interesting part of this video, which is going to be hooking up that stamp and getting the Hopper virtual machine running on it. Thanks for watching.